Hey, I'm Jenn.
Hey, I'm Pam.
Hey, I'm Janelle. And I'm Rachelle. Okay, this week's topic is solid earth, and our complex question is, what affects erosion?
And the fifth member of our group is Austin. He's my son. He's 9 years old, and he's going to be our elementary student perspective on our experiment. Okay, so our first testable question was, how does the slope or incline of the landscape affect erosion? So Austin, what do you think will happen if we pour rainwater on soil that's like this, or rainwater on soil that's like this?
Well, if it's not much down, then I think small amounts will fall. But if it's more down, then I think more bigger amounts will fall.
Okay, let's test it and find out. So this is our first incline, and we're going to pour water on the soil that we've already packed down with a little bit of water to keep the variables the same. There is some runoff, and there's sediment running along all of the runoff. Okay, for this portion of the experiment, we took 3, what are these, 2-inch? 2-inch binders underneath to significantly raise the incline. And you can see the water ran much quicker, and there's larger pieces of sediment coming down, and there's much more of it. Okay, after watching the second incline, we were curious to see what would happen if we put more water and raised it even higher. And here we start to get a little bit of a landslide and large chunks of sediment rolling down. Okay, now that we've finished our experiment, let's review the question. How does the slope or incline of the landscape affect erosion? And our claim was, increasing the slope or incline will increase the amount of erosion on the landscape. And like we showed in the experiment, when we had it slightly inclined, we did have some sediment come down from the main pile of dirt. When we inclined it using 3 binders, we had a lot more sediment come. And when we actually held the tray up even higher, there was large chunks of sediment that fell. So as we increased the incline, more soil was eroded and more sediment gathered at the bottom of the tray. So Austin, it looked like your guess was correct.
Okay.
Our second testable question is, how do the roots of plants in soil affect erosion? So what do you think will happen if there's soil with no plants and soil with plants? What do you think the difference will be?
I think if there's no plants at all, then the erosion will be easier to go. Okay. And if there's plants and a bunch of rocks everywhere, then it would be harder to go because they're all making it not go.
Okay, let's find out if that's correct. At this incline, in our previous experiment, we saw a small amount of runoff after pouring water onto the soil. So this sparked our next question is, how does soil erode when there's roots of trees and bushes in the soil? So we're using Kleenex to represent the roots of trees, and we're going to apply water and see what happens. So you can see the water spreading out through the Kleenex, and now it's starting to run down.
We see a lot less sediment.
Okay, let's review our testable question. How do the roots of plants in soil affect erosion? Our claim is that roots and plants in the soil will decrease the amount of erosion. So as we saw in our experiment, we had 2 trays, both at the same incline, one with dirt and one with tissue on top of the dirt. So our evidence, since the tissue demonstrates how roots help to form a bond on the earth and protect the soil from erosion, there was less erosion with the tissue. So, you were right.
All right, our last testable question is, how are different types of ground affected by erosion? So Austin, what do you think if we had sand for the ground and dirt for the ground? Which one do you think would erode more?
Well, I think sand water would be able to get through because sand is sometimes smaller, and it's easier to get through. Why dirt, it has a bunch of twigs and clay and chunks, which will make it harder to get through.
All right, let's see. All right, our final testable question is, how does the type of ground affect erosion? So now we're going to use sand to represent a finer soil type than our coarse dirt. We already wet the sand because we used wet dirt in our previous experiments. Keep in mind that we are keeping the incline the same. So now we're going to pour water and see how it affects the erosion. 1, 2, 3, 4. As you can see, the runoff is much greater than in the coarse dirt. All right, let's review our final testable question, which was, how are different types of ground affected by erosion? Our claim was sand, which is the fine soil, will erode more than the dirt, which was our coarse soil. And our evidence, as you saw in the experiment, at the same incline, the dirt eroded slightly, while the sand was eroded so much that it flowed down the tray. So, Austin, it looks like you were correct.
Yes.
Okay, we hope you enjoyed watching our experiment. We'd like to give a special thank you to our special helper, Austin. And remember,
Science is fun!
I guess you have to have a problem if you want to invent a contraption. First to cause a train wreck, then they put me in track.
A lot of sediment fell, and actually big chunks fell as well. So, Austin, it seemed like you were right in your guess. Oh, wait.
yeah, she's
I'm sorry.
we had 2 trays at the same incline. One with just dirt, one with Kleenex on top of the dirt. Why am I saying Kleenex? One had just dirt and one had Kleenex that we laid over it to act as roots of different plants to bind the soil together. So, once we poured the water on each one, sorry.
Alright, our final testable question is, how does the type of... Okay, for our final testable question...
Okay, we hope you enjoyed watching our experiment. We'd like to give a special thank you to our